Also, John, I believe they can pick up that form at the command post. If you so choose that you want to get your house monitored again, you can just go to the command post and they have the paperwork there, and then you can leave it there. Next is Ms. Deborah Saxon with Shaw.
Okay, I'm Deborah Saxton, Shaw, Project Manager. Our agenda for tonight, since our last meeting about 3 weeks ago, we'll cover these, the update on these activities, the venting of the observation recovery wells, the shallow gas migration and the pressure monitoring results from the geoprobe, the shallow geoprobe wells that are installed in various areas. We'll also provide the area of the potential gas accumulation in the Mississippi River alluvial aquifer. And we'll give you a status of the sinkhole and the cavern activities and findings, and also provide a conceptual understanding of the current situation as we see it, and also the rock mechanics modeling that we will be performing through our consultant, Itasca, for the stability analysis. We have, in the last few weeks, we have completed the construction of observation recovery relief well. I'll eventually get used to this. We've completed the construction of the observation relief well, ORW4. We began flaring this past Sunday, and so at present we're venting from ORW4 and also venting, Texas Brine is venting from their well. We have also re-perforated ORW2 on the Dugala Blanc property, and we plan to be flaring as early as tomorrow from that well as well. If you remember the 3 wells that we do have in ORW 1, 2, and 3, we found that the perforations were plugged, so that's why we went back into ORW 2, and we have plans to do the same for the other 2 wells on the Trish property and the other one on the Dugala Blanc property. So we're currently flowing about 15 to 30,000 cubic feet per day from ORW4. And we have formation pressures between 50 and 90 psi. This is slightly greater than water pressure with the column of water that we have in the wells, and but slightly less than what you would expect the pressure to be in order to break through the ground, to rupture the ground, that you would see that disturbance at the surface. In ORW, between all our wells, ORW 1 through 4, we have between 5 and 30 feet of gas that we can see in the PDK logs. And 5 and 6 feet at the Dugala Blanc properties. We don't see a column of gas at the Trish property, ORW3, and it may be that we don't see it because the lithology that we have, the fine-grained soils that we see in the log, we may not be able to see the gas accumulation in that interval. We did see two separate gas columns in ORW4, and that's the well that's south of Highway 70. And, but effectively, we have about a 30-foot gas column, and that's all dependent on the lithology that we have there of what we can see in the log and what we can't see. Our next steps, we're going to be adjusting the water column in ORW 4 to improve the gas flow, lower the water pressure in the well. We're going to flare ORW 2 tomorrow. We're also going to begin cleaning out ORW 1, which is also on the Duval Woodlawn property, and reperforate the interval there. We plan to use a common flare for ORW 1 and 2, given their proximity. And we also plan to clean out ORW 3 and reperforate that. And at this time, we plan to use that as an observation well until such time we can determine if that can be effectively vented. And at the end of November, the operations and maintenance of all 4 of these wells will be taken over by Texas Brine Company. I'll turn this over to one more. Okay. Just to show you where the wells are, we've got ORW 1 and 2 here, ORW 3 on the Trish property, and this newest well is ORW 4, right south of 70. Here's the sinkhole. And Dr. Hecox will take over right now.
We are a team, believe it or not. I'm going to start off with, I'm going to present the shallow gas results. These are the results from all the geoprobes we put in and around the community. And you'll see going through this why DNR has requested DEQ be allowed to go in and monitor your homes again. These geoprobe wells are, 20 to 40 feet deep. The gas is predominantly methane, is what we're detecting. We do have pressure in a number of these wells, positive pressure. And as I go through here, I'm trying to define some terms so people understand a little bit. I try not to use complicated terms, but sometimes my technical background gets the better of me. When I talk about formation pressure, this is the pressure in the gas body and not necessarily the pressure you measure on the surface. The reason is if you have a column of water in the well, that will tend to resist some of the pressure from getting to the surface. So you may have 5 psi at the surface, but your formation pressure may be 10 or 12 psi. So when I talk about formation pressures, I'm actually talking about the pressures in the gas body. And all of our analysis that we do in terms of remediation and everything is based on the formation pressures. This is some more definition of the shallow geology. This is an idealized section, but we have about 100 to 130 feet of clay. This is what's right below the houses and everything. It covers the entire area we're investigating. Below that, in a number of places, we have a silty sand we talked about last time. A lot of the gas is accumulating in the silty sand, and that's going to limit the flow rate because it's less permeable. The gas can't flow through it near as well as it could a sand or gravel. Below that, we have the Mississippi River alluvial aquifer, and it's between 300 and 400 feet thick. So this is kind of the geology we're looking at, and all of this is above the salt dome. The monitoring locations are shown here. What we've done is put all these together on one map. The bubble sites are the little orange triangles. The sinkhole is here. The shallow geoprobe wells are these blue circles with crosses in them. So we have geoprobes all the way from the east side over across Bayou Corn to the west side. So we start east of Grand Bayou and cover this stretch through here. The edge of the salt, you're going to see this brown line a lot on the figures. This is the 1,000-foot contour on the edge of the salt. And because people wonder where the salt is as we go through these presentations, the brown line defines the edge of the salt. Of course, the sinkhole is fairly predominant now, it's right there. The shallow pressure results, here they are. We do have positive pressure over in most of the wells across the monitoring area. They range from very, very low, like 1/10 of a PSI, which is equivalent to probably about that much water in terms of pressure, up to 11 and 12, 13 PSI over here. We do have 5 PSI on the east side, and you can see the numbers. These are the maximum readings we recorded over the last 3 weeks since we got our calibrated gauges in. We have observed bubbling in 2 of these wells when we open them up. They're normally sealed. We take the pressure, and then to do that we open the valve, and then we do a water level so we can calculate formation pressure. 2 of the wells do bubble inside the casing when we open them up. One of them is over here on the east side, and one of them is up here on Sauce Pecan Gumbo Street, right there at the intersection. We have had 2 wells that when we were either monitoring them or sampling, they did lift the water column out, which meant there was enough pressure down at the screen interval where the water column would lift out. Those 2 wells, one of them was here on the Dugas-LeBlanc property, and the other one was over here in the corner of the community. The low pressures you see here, we're fairly sure, even though we've recorded them, these are probably related to atmospheric pressure changes and not necessarily gas pressure. And we're working through that on at what pressure do we think we have potential gas flow versus barometric pressure. Because as barometric pressure changes, these sealed wells can change pressure, and we're working through that. But these are the observed pressures. Just because you observe a pressure doesn't mean you've got gas flow at that location, though, especially at the low level, at the low pressures. We have calculated formation pressures over this entire area, and we know we have gas over this area because we have bubbles in the bayou, and we've got gas in our vent wells. We know we've got gas at the top of the aquifer. When I calculate the formation pressures in the shallow part up in the clay, they come out about the same, which means it appears that whatever's causing the pressure is affecting the area of gas as we know it, and it's affecting all these shallow wells.